Hello and welcome to Taiwan Talks. I'm Ian Kavat. Does the United States call Taiwan a friend when it comes to semiconductors? And could diversifying the manufacturing of chips be the industry's undoing? Today, we discuss TSMC founder and former chair and CEO Morris Chang's recent comments and the implications going forward. I'm joined today in our new studios by Tri-rung Yew, National Tsing-hua University Department of Materials Science and Engineering Distinguished Professor, former United Microelectronics Advanced Technology Development Vice President, former Semi-Taiwan Women in Tech Advisory Council, and former Semi-Taiwan IC Forum Chair, and Tim Culpen, Bloomberg opinion columnist, former Bloomberg technology correspondent, and an expert in supply chains, China and semiconductors, and Marco Mesger, Neumünster Executive Vice President and Chief Operating Officer, Memphis Electronic President, and he is an expert in memory and semiconductors. Professor Yew, Tim and Marco, very warm welcome to the show. Morris Chang has warned against chip diversification and said Taiwan wasn't included in the US's list for friendshoring, which is relocating supply chains to countries with shared values. He made the comments at an event in Taipei organised by Taiwan's Commonwealth magazine. Chang was in conversation with Chris Miller, the author of the FT Business Book of 2022 and global bestseller Chip War.
And friendshore does not include Taiwan. In fact, the Commerce Secretary has said repeatedly that Taiwan is a very dangerous place. America cannot rely on Taiwan for chips.
Tim, let me come to you first. Can America rely on Taiwan for its chips?
I think that's really a loaded question. Everybody is reliant on everybody else. So Taiwan is no less or more reliable than anyone else in the supply chain, whether it be Japan, South Korea, Singapore, Israel, so many other countries that are in the supply chain. So this idea that the Americans have been bringing up in the last few years that Taiwan is dangerous, it's unreliable, we shouldn't rely on it, it's kind of a bit of a misnomer, because there is definitely parts of the supply chain that the world relies on when it comes to Taiwan, TSMC being most famous, but in fact there's a lot of other companies. UMC, for example, they're not as big as TSMC, but they're a very important part of the supply chain. We have MediaTek in Taiwan, also very important. They're a chip designer. Their chips are in a lot of products, and if they were to have problems, then the world will also have problems. And then we've got material suppliers, we've got a lot of companies that make things like microcontrol units and power driver ICs. So Taiwan is a very important part of the supply chain. And yes, if Taiwan was knocked offline, the world would be in trouble, but that would be the same for anywhere else. So the idea that somehow Taiwan is reliable or unreliable or can't be relied upon, I think is a misnomer that really matches what people in the US want to hear and want to say to push their own agenda, especially as it comes to developing a US chip industry.
Marco, but Taiwan is the one that's under threat from China. Is it not a dangerous place?
No, it's not a dangerous place. I think what Tim mentioned also, I think there are many dangerous places in the world, where you have to watch out for the supply chain. I think it's a great place, Taiwan, especially for the semiconductor industry. You have like a very good ecosystem from design houses, foundries, manufacturing. So if you want to do something in semiconductor, you want to achieve something, you have the best setup here in Taiwan.
So Marco, are the other places that you say Tim mentioned, are they dangerous because of their proximity to Taiwan?
From a business perspective, I would say the geographical region is not so important, because you have in Israel, you have foundries, you have basically factories there which are there. You have in Japan, you have also factories close to China. So I think at the end of the day, what is important when you ask me about is Taiwan a dangerous place, is it like, do I feel threat when I personally live here or I conduct business? And I don't feel this, because you have here like a very good setup to do the business.
Let's have a look at President Lai Ching-te's, William Lai's comments. He attended the event, which was a conversation between Chris Miller and Morris Chang. So he said the world's development needs TSMC, and democracy is like sunlight and water to TSMC. I hope that the democratic camp of the world would cherish the achievements of TSMC, value the democracy in Taiwan, and work together to maintain peace and security for Taiwan, TSMC, and the world. Professor Yew, is the VP right?
Yes, I fully agree with his point, because Taiwan is so important and indispensable, especially in semiconductor manufacturing. We are so friendly and we are a good partner, and also a very close collaboration with our friends, trustable. Yep. So it's very hard to find such a good partner in the worldwide. So I think in this, in the future, there will be some mainstream on the democratic camp for the semiconductor chip manufacturing or the products production. So it's very important that in this democratic camps, with the Taiwan and TSMC, all the manufacturers in there. That's very important. And democratic countries, because they emphasize the freedom and the free will. And also that is the base of innovation. And also the respect and human right, and also the protection under law. That is the base for collaboration. That's why in the past, the Taiwan has a close collaboration with the democratic camps. So that is, in the future, it will be a big loss without Taiwan in there. And that is also benefit all the human beings and make the world better in the future. Yeah.
Tim, Professor mentioned that, free will, freedom, this spurs on innovation. Did you get anything else from the VP's comments?
Yeah, I think to that point, I totally agree. When a society is allowed to be creative, is allowed to step outside the boundary, that's where innovation comes in. That's where you discover something that you weren't looking for. That's when you stumble across ideas, because you were given the freedom to go and explore those ideas. You're given the intellectual freedom, the academic freedom, the political freedom, and of course the financial freedom to explore new ideas. And so we have come across in history of innovation a lot of kind of these Archimedes moments where, oh wow, we just discovered something amazing. If you close in a group of people and say you can only work within these boundaries, color within these circles, then you are going to naturally limit it. You will definitely have good engineers, you'll have very good people who can execute on something, but the free flow of new ideas, which is very, very important, especially for the semiconductor industry, which is governed by or follows Moore's law, we always have to discover something new. We're always coming up against new technological barriers. And without the ability to have that freedom to try things, to make mistakes, and have that freedom to try something that you wouldn't have otherwise thought of, that's where we can have that technological advancement. And so while democracy directly is not necessary for that kind of advancement, it's the environment that democracy gives you that allows people to think freely and come up with these new ideas.
So Marco, should democracies around the world help to protect Taiwan and protect TSMC, if that's the case?
As I think Tim mentioned, it's collaboration, right? So the more you collaborate with the outside world, not only concentrate in one area, so you go to Europe, you go to USA, you go to other countries, you collaborate. That's how you basically have an exchange. And that's how this industry is thriving. If you think about semiconductor, you have so many steps to make a product. It's not one company. Even TSMC is there. They cannot do it alone. They need materials from Japan. They need equipment from Europe, from the USA. So it's all about collaboration, and this should not be controlled or bounded by governments. Free flow of information is very important that the industry thrives.
Yeah, in fact, I think Zhang has said in the past that TSMC can work with 100 companies, or does work with 100 companies, whereas in fact a company like Intel only works with itself. I think that's one of the comments, isn't it? Tim, let's talk about, because I think this is connected, the Silicon Shield. So the Silicon Shield that supposedly has been protecting Taiwan, is there a Silicon Shield, or is this actually a proxy for the US?
The concept of a Silicon Shield has been around for not just the last few years, more than 20 years. It was given rise to, in the late 90s, early 2000s, that word came up. And that was before TSMC was as fundamentally important as it is today. And so it's now been revived because of all the geopolitical tensions and the fact that suddenly the world has woken up and realized, oh, we need TSMC. Oh, we are really, really reliant on Taiwan. And it's not just TSMC. I should point out that another famous Taiwanese name, Foxconn, is very, very important to the supply chain, and we tend to forget about them. So the idea of a Silicon Shield is bandied about now really for geopolitical reasons. People say, well, that's the reason why we would or wouldn't defend Taiwan. There's a lot more reasons to defend Taiwan than some semiconductor factories in Hsinchu, but that's a geopolitical issue for political decision makers to make in Taiwan and around the world. But the idea of a Silicon Shield, I think, is a convenient term to point out why Taiwan matters in a very specific area of the global economy, which is, electronics and semiconductors.
I want to pick up on something that you said earlier. You said that that people might be, pushing these narratives because of their own agendas. For example, that Taiwan cannot be relied on or is a dangerous place. Could you elaborate?
Well, I think there's a lot of people in industry outside of Taiwan, but also in Taiwan, but outside of Taiwan, especially in North America and in Europe, who want governments to put out money to help bring back semiconductor industry or revive a semiconductor industry. And so they need these narratives to talk about why Taiwan might be a dangerous place, why it's too concentrated. And that's a narrative that's really as much for politicians and bureaucrats as it is for industry, because that narrative is very important to get money out of governments. And as Dr. Chang himself has pointed out, if we're in a global free trade environment, then TSMC probably wouldn't have set up in Arizona. The costs are much higher, 50% to 100% more expensive. And so without a narrative to justify that kind of expenditure, we probably wouldn't be seeing the talk that we've seen in the last couple of years about TSMC setting up shop in Arizona, possibly in Europe. They're doing a deal in Japan and expanding in Japan. A lot of these things possibly wouldn't have happened without the idea that Taiwan is something that we need to worry about.
Marco, let me put to you something actually that Tim has written. He said, his conclusion after attending the event with Morris Chang and Chris Miller was that Taiwan's not feeling the love. So very well, sort of very concisely put. And also Tim just mentioned, of course, the Arizona plant. So is there a sense in Taiwan that, Taiwan has tried to keep up its side of the bargain, but seems to be feeling that, well, it's not listed on the Friendshoring list. So obviously there are implications for that.
Right. No, I think I like this sentence very much. It's not feeling the love, because if you're talking about Silicon Shield, it's also like silicon competitiveness, right? So I think in Taiwan, you have such a strong industry with the newest technology, what has built up, not like in 5 years, in 10 years, in 15, it's like more than 30 years. And all these investments where the governments are putting money in, they will not be able to copy this. So the largest customers from TSMC are US-based customers, right? So they are helping customers to make good profits, to make great products. And of course, in return, they are called we are called here like a dangerous place. That's not love, because I think it's their own agenda, what Tim mentioned. So they follow their own agenda, they want to get subsidies. But frankly speaking, with the subsidies which are issued at the moment, they are not bringing a complete ecosystem there. This is probably here and there you have like a factory, and it's good for the global supply chain balance. But to copy this, and like we have this here in Taiwan, it's like the educational system has to come with it, the government has to put into with this, and of course you need to also have some kind of a base infrastructure to make this happen. So definitely the love at the moment, I would say, is not felt.
Professor Yew, so is there a sense that Taiwan's being punished twice? It's under threat from China, and then it's being cut off from a friends list. It's not being treated as a friend. Taiwan, at the moment, as we all know, is very central to the global supply chain. But what are the implications of not being on this friends list, going forward? Could de-Taiwanification occur? How quickly?
Well, I don't think it will occur. It's very unlikely to occur. The reason is that in free trade, right, in the free countries, always look at the cost and performance. So, in Taiwan, we have been dedicated, also focus on the manufacturing excellency. So to get a high yield, low cost, time to market, cycle time, and also the talents. They are also hardworking and honest and trustable, and also so friendly to collaborate with the worldwide suppliers material suppliers, equipment suppliers, or customers. All those advantages is very indispensable and hard to catch up or copy in a short time. So even naturally, actually, Taiwan is already in the friendshoring. It's already in, but you know, in the long run, I still think that will be also in there. Yeah, and in terms of the cost and increase for the diversification, I think definitely it will increase the cost and also the development cost and R&D investment. But you know, if you look at the advantage, there are some advantages close to the end customers and local recruitment of the talents, and also you have a resilience to face the challenge and risks. But you know, all the healthy company, they already balance the between the diversification and the focus. So in the long run, Taiwan is still in the key player in the democratic countries in the camp. So I don't think even the wording is like that. We're still looking to find a ways, and then we still will be contribute to our excellency on the manufacturing, no matter in the foundry side or in the packaging side. That's what I think.
Okay. Tim, what's your view on that?
Well, I think there is a point to be made that, for example, TSMC is too concentrated on Taiwan. It has, more than 90%, perhaps more than 95% of leading edge capacity, and it's all within about 150 miles. And that's whether or not there was an issue with China. We also have an island which has water problems. We have typhoons. We have earthquakes. It is a weird thing that I think Chris Miller pointed this out. A lot of semiconductor manufacturing is set up in earthquake zones. Silicon Valley, Japan. Taiwan. For some reason, executives like setting up fabs in earthquake zones. That maybe needs to be looked at. But it does make sense for people to say, well, hang on, look, TSMC is awesome, but it's all concentrated in one place. There's a reason for it. There's a lot of benefits to that. These fabs run 24/7. Engineers are often shuffling between, say, Hsinchu and Tainan and Taichung in the middle of the night. And so if you're setting up in Arizona or in Dresden, which may happen, of course, in Japan, you don't get that ability to just swap around and kind of troubleshoot problems. So there's definitely a point to be made about decentralizing away from Taiwan. I think it's the approach to it, though, and the attitude that's taken to it. There needs to be set up a better system, for example, in the US and in Europe, to bring a lot of that value back. But it should also pointed out that the US is not, nothing in the supply chain. Most of the value actually is still in the United States.
We're going to go on to that in the next section.
And so the key point is that this decentralization is important, but you really need to break up the chip industry into slices and look at each slice and say, where is the concentration within these slices?
That's a great lead into our next section. The TSMC founder said the United States controls around 40% of the entire global supply chain. We have a diagram up here. There's design and verification, foundry, assembly, packaging and testing, contract manufacturing, OEM, which is original equipment manufacturing and products, and finally customer specification. Now Taiwan controls around 60%, as we've mentioned, of the foundry stage, and it's also involved to a much lesser extent in assembly, packaging and testing. Marco, so does Zhang have a point that in fact the global supply chain, when you look at it in its entirety and not just focus on manufacturing, is already diversified?
Well, it's diversified for certain domains, right? So I think, as you pointed out, a lot of the IC design houses are basically in the US. I mean, Apple is designing their chips in California. Then you have Qualcomm, you have other companies who create a lot of value in the supply chain. But when it comes to manufacturing, as Tim pointed out, every company today needs to do a risk assessment, right? Fukushima, many years ago, where there was the big tsunami, has shown there was a lot of the epoxy manufacturers who were there. They were all in kind of a circle, a very important ingredient, for electronic manufacturing. So these are some basic questions where I think the concentration is, from a business continuity plan, not really healthy. So something had to change there also, even if it's centric in China, where there was a lot of manufacturing also here in Taiwan. But I personally believe the combination, if TSMC or other foundries are going outside is bringing them more together with their customers who are there and with people there. So what Professor mentioned before in regards to the discipline here in Taiwan, this is a different level because people here from the university to the foundries or to the companies where they work is highly, highly disciplined. It's a different workforce than, for example, in the USA. And I think there have been numerous reports already about this, that this is a huge challenge, the talents.
Yes, and Tim, obviously you were at the event, so you know that Morris Chang actually used a comparison, a story where he talked about Texas Instruments, which then relocated a fab to Japan, and I don't know if you can recall that story, that he talked about the efficiency comparisons between the staff there.
Yeah, I mean, this is something that, as we know, Morris Chang was at Texas Instruments more than 50 years ago, and this is something that they've found even 50 years later, is that there is an efficiency gain by moving to, say, for example, Taiwan. One story I heard during the recent kind of chip crisis, and it may be apocryphal, I don't know whether it is actually true, but apparently a senior political leader in Europe called up Taiwan and kind of said, can't you run the chip fabs, 24/7? And of course the laugh on the other end was, we're already doing that, right? I mean, this is the thing. If a factory goes offline, if TSMC has a problem with just one machine at 2 a.m., and Morris Chang was talking about this, you would have an engineer, woke up in the middle of the night to get to the factory within the hour to fix it, whereas maybe in the US they would, fix it in the morning. Every minute, every hour is very, very crucial to running a chip factory. And so there's that work discipline and that approach to efficiency and discipline, which is crucial to the chip industry, because there are so many parameters in making a semiconductor that you have to be very, very focused on that discipline. It's a work discipline, it's a technical discipline that we're not really seeing in the US, but the US has different disciplines that they're very, very good at. The best software for designing a chip is in the US, and in fact some of the biggest chip companies in the world are American companies such as NVIDIA and AMD and Qualcomm, because they have different strengths that they work on and they focus on. That's the rule of comparative advantage. We don't have a strong design industry in Taiwan. We do have MediaTek and some others, but they're nowhere near as big as, say, Qualcomm or NVIDIA. So if we focus on what we're good at and what we're not good at, and really divide up the industry that way, we have actually had over the last 50 years a very good ecosystem that companies like TSMC have been able to unlock.
That's right. And Marco, because the US and Japan decades ago also were the hub of manufacturing, but then that gradually shifted. So there has been a diversification that's happened in the chip industry. Is it only natural, therefore, that in the decades to come that there might be further diversification?
The question is, what is the diversification driving? Is it like competitiveness? Is it like basically purely business orientated, or is there influence from politics, right? Because they can shift it, especially the subsidies you see. I mean, these are stunning sums. If you look, for example, Intel, they ask for 7.7 billion, I think, in Europe, and now they say, oh, we need another 5 billion more. So we talk about 12 billion. That's basically cost of a fab, what you can do. So, and these are companies who made a lot of money, right? So I think it's not these are poor companies that you help a startup. So it's like they made a lot of money, and the intention is from these governments, they want to start another Taiwan. So they have this idea, we get Intel there, then of course if Intel comes, then also you need a packaging house, you need the material, you need the gas supplier and all of this. You need to do this, but I think Morris Chang, he mentioned a few times, this will make the supply chain more expensive, and that's a fact. It will be more expensive because you don't have it so concentrated. But what's the price for it? We talked about more resilience in the supply chain, more diversification, so you need to pay a price. So the question is how much you can stretch this, how big of a place you want to do in Europe, how big of a place you want to do in the USA. That's really the big question, how strong the diversification should be.
Finally, for this segment, Tim, there was a breakthrough when Japan said that it would lift the export bans on some crucial chip materials to South Korea. Can you just explain to us the significance, of this move? What does it mean for the industry?
Well, I think there's a few takeaways from what happened. So in 2019, because of basically Japan-Korea tensions that really date back a century, Japan decided, well, we have a certain strength over Korea. and we're going to cut off the supply of 3 major chemicals that are used in the production of semiconductors. And that was very similar to, in fact, what the tension we've seen in the US-China relationship. So it shows that there's not just the US-China relationship that has tensions or has bottlenecks or choke points. Even in the Japan-Korea relationship, there's a choke point there. And so the Japanese, figuratively cut off supply. Now, in fact, there was a loophole where they said, well, we'll export it with a license. So the Korean companies did actually, over the last few years, go back and get licenses, or the suppliers got licenses to export. So if you look at the trade data, most of those chemicals, the trade still kept flowing and still kept going. So it was very symbolic when just recently they said, the Japanese government said, all right, well, we'll start letting it flow again. But the point being that, there is choke points that governments can, at will, cut off supply of, whether it's materials, whether it's IP, whether it's semiconductors themselves. And we're all reliant on the whim and the policies of governments, even when it's not related to the semiconductor industry. And so the significance here is, well, it's a warming of ties between Tokyo and Seoul, which I think we'd all welcome. But it also shows that no part of the world and no relationship, no bilateral relationship is immune to geopolitical issues that can affect the rest of the supply chain in any industry.
Thank you.
One point I just would like to add to this one. Tim, remember when this happened initially, there was also then the Koreans, they started to finance and build up this capacity in Korea, also in South Korea, right? So SK Hynix and others say, okay, we will build up more capacity to be resilient, if this is happening. Because
so they made their own chemicals.
Yes, so they basically, they build up some more capacity. Of course, still Japan has the biggest share there, but this drove the decision. So they say, okay, we will limit this. Even they got the paperwork always done. South Korea said, oh, this is something where we have a choke point, we need to do something, and they take action. And that's why all of these kind of limitations, if you do this, then you drive basically the development
innovation
in another direction, so that you will be more resilient to a certain point, right?
Yeah, and that is something that critics of Washington's policy say about what could be happening in China. Washington is making it even harder for firms receiving US grants to expand their operations in China. The US Commerce Department has further tightened rules under its CHIPS Act. Any firm seeking to grow production in China above certain levels of expansion will be restricted. The new rules would affect companies like TSMC, Samsung, and Intel. Now, also blacklisted Chinese telecom Huawei has claimed its circuit board production has stabilized. The firm's CEO said it had replaced 13,000 products hit by US sanctions and redesigned 4,000 circuit boards. Huawei was added to a US trade blacklist in 2019 for its alleged close ties to Chinese state intelligence. But the Chinese company continues to receive billions in US goods thanks to a Trump policy which exempts below 5G level chips, according to Reuters. Marco, how significant is Huawei's claim that its circuit boards have stabilized?
Well, I cannot go through the list with the 13,000 pieces, but I would assume that this is doable. This is doable, that you can make this. So I've seen during the shortage and the supply issues during COVID that there have been a lot of new China suppliers who help also, let's say, like the Western companies where they designed this in. So they basically developed, and we are not talking about cutting edge technology. We talk about power ICs and others who have been high demand because of the notebooks and others. So I think it's possible that they could do this and replace it.
And is it, in a sense, worrying?
Well,
it's going counter to what the US wanted.
Yeah, but that's what I mentioned before. If you cut one supply chain, they will not sit back and say, oh, okay, now we cannot make products anymore. This is, I think, every country, every company would try to survive and find a solution. You mentioned before, they try to find another innovative way in order to get around this. I think it definitely slows down. That's basically how you can see the sanctions and what is happening. So it has an impact. I don't think it has an impact that there is no progress, but it significantly slowed down. Because if you have seen this before all the sanctions come, how fast it was basically growing, and how much slower the pace is right now, and the reshuffling with all the new regulations which are coming in.
Professor Yew, would you like to comment on, what significance this has for the US-China chip war?
Yeah, and I think what you mentioned, the Huawei's case, right? Though they claim they have some parts replacement, but you don't know how's the performance. You don't know what's the definition of stable, right? So as I think, I agree Marco's saying that it definitely will slow down their progress, because especially for the high end, no way to catch up in short time. But for mature node, the performance-wise, still a question, right? And but though they find a way, but the thing is, for the high end, it's very, very difficult to catch up in the short time. So all those they can do is slow down their progress instead of just they would never happen in the future, right? So, but in terms of performance-wise, in terms of advanced technology nodes, I think that's very difficult. They will have a lot of burden to replace the parts, and they have the fundamental-wise for the advanced technology. That's very crucial. And how about the fundamental-wise? Can they deliver that? That is, I'm not sure about that. Okay.
Tim, we talked about the new round of restrictions. What do you make of that? A further tightening of the rules for companies that want to get the US grants. How effective do you think they'll be?
Well, the thing about the CHIPS Act that was passed last year is that there's so many provisions within it, and we're only starting to see what some of those provisions are. Some of them were clearly laid out in the law as it was passed by Congress, and others are just kind of being brought out later by various parts of the US bureaucracy. One of them is, for example, that anyone who receives grants can't buy back shares. So that is probably a good idea, because that's how companies prop up their stock prices, and many executives are compensated according to the stock price. So they're not necessarily incentivized to put the money in the right spot. But then there's the issue of, okay, if you're not allowed to spend any money in China, if you get CHIPS Act money. On the surface, that sounds, well, I kind of get that, they're our enemy. But imagine you are a US semiconductor maker that's already got operations in China with old technology, and a piece of equipment fails, and you just want to replace that piece of equipment. Now, if you look at the financial report, the income statement and the cash flow on the balance sheet, that would be considered CapEx. That would be property, plant, and equipment. Now, it's not new equipment. It might be something very old. But depending on how these rules are structured, you could conceivably have a company that's been operating in China for 20 years, very old technology, suddenly sitting there idle because one piece of equipment can't be replaced because they took CHIPS Act money. So the devil will definitely be in the details. And I think we'll see a lot of pushback from companies, not just American companies, but any company who is getting CHIPS Act money to say, hang on, that's not fair, or you need to clarify, or we want this exclusion or this exception. I think the way it would play out is that that'll be a blanket kind of exclusion or ban, and then companies will individually go back to the government and say, please give us an exception for this case. But the problem is that could slow things down. The chip industry moves very quickly. If you've got a piece of equipment sitting in a factory in, say, Nanjing or Shanghai that's sitting idle, you don't want to sit around 6 months waiting for the Commerce Department to tell you whether or not you can pay $5 million to buy a piece of equipment that's going to get a factory up and running. So there's definitely a lot of instability that could be coming in the future for those who are operating in China. Even if they don't plan to expand operations in China, existing operations could still be affected.
Yeah, a very good point. Marco, I mean, you're in the memory industry. South Korea obviously is going to be vastly affected. It has many factories in China. How is this being received on the ground by the companies?
You mentioned it. I think if you look, for example, Samsung has a majority of their NAND flash production in Xi'an, right? So we're talking about 250,000 wafer. That's around about 40 to 50% of their global output. SK Hynix has in Wuxi DRAM factories, which is accounting for 15% of the global DRAM supply, right? It's also around about 50% of their output. It's significant. And this is technology where, for example, on the DRAM, we are definitely going down to below 20 nano, right? So this is this technology, and I think it's very challenging to see this, right? Because these factories, like Tim mentioned, these decisions have been made before. The capex has been spent there. It's like double-digit billions what has been done there, and it's also a huge market for these companies. So it's one thing is like the supply. You know, if this supply would go back, it's not so easy to replace this in another area. And the other thing is, for example, if existing equipment is breaking down, how are they able to maintain this? Can they maintain it? So, as you mentioned, the devil is in the detail there. And they have not officially applied yet for this. This is also important to understand. Samsung and SK Hynix have not applied yet for the CHIPS Act.
Right, right. But they are expected to.
They are, but I think they want to see the details, I would say.
Professor Yew, would you like to comment at all? I mean, because we talked about South Korean companies, but United States, American companies are being affected by this too, not very happy.
I think most companies will find a ways, right? They need to survive. So I would say that still there will be the mainstream for the alliance between the democratic countries for further development. Like Japan always work with Taiwan closely. They are very good at the materials, outperforming materials and equipment. And United States the same. So they will still continue with the Taiwan for the further advanced nodes or future collaboration. So because this is a free country, right? And all the business companies, they want to have the profit. So I would think that it still continue. The government have that kind of restriction, but it only to some country. But the democratic parties still they will work very closely. So in the end, still will benefit from that kind of partnership. That's what I think. Right.
Tim, a very good point. Why is Washington coming out with more and more restrictions on China? What is it that China can do with these chips?
Well, the chip war is really part of a broader war, which is, we've seen essentially a Berlin Wall of technology, which started really 10 or 15 years ago, even before Donald Trump got into power and started shining a light on it. It's been quite obvious to a lot of people watching the supply chain that China and the US, or the Western alliance, which I would include Taiwan, Japan and Korea in that, it's been bifurcated. It was kind of inevitable. China has been trying to develop its own technologies and cut off Western suppliers or foreign suppliers when it can. The Americans and the kind of this alliance have started more recently to realize, we are very, very much dependent on China. And then, of course, there's this rising tension between what is the global hegemony and what may be the future global hegemony that wants to have a greater position in global power. So you've got these two competing powers, and the US is fearful of that. And semiconductors are a very important part of now. Now we think of kinetic war and guns and bombs and so forth and planes, which all need chips. But cybersecurity is a very important part of defense. And there's so many other things that would happen in the geopolitical sphere that is not even within wartime, where chips are so crucial that whoever has the chips, whoever has the technology, and beyond the chips itself, the hardware, the software, the AI algorithms, all of these things that really are part of the global semiconductor or the technology industry, these are all very important. We're seeing it right now at the chip front. There is a book out there called Chip War that Chris Miller wrote, but we are going to see AI wars, we're going to see software wars, we're going to see materials wars. Lithium will be also a big thing because that's very, very important for batteries. There are so many other esoteric chemicals and parts of the whole supply chain that we really don't know about that are also going to pop up over the next decade, and we'll start realizing, that piece of equipment is really important. That little known chemical that we'd never heard of is really, really important. Rare earth metals are one of them that keeps popping up every now and then. And the US is very fearful that China will be stronger than them. So they're using what they have, which is their power in the supply chain, in the semiconductor supply chain, to try and hold off what they see as their rising enemy.
And Marco, in terms of Taiwan, of course, Taiwan is under threat from China's military, which the US is trying to restrict chips to stop that military from modernizing and being able to attack Taiwan. Is that correct?
Yeah, I think especially when you look into AI, you need to have like the newest process nodes, right? You need to have the newest chips. Military has also a lot of legacy nodes, right? So don't forget this. So there's a lot of components which basically are also going into military because they are served for a very long time. But the intelligence and the computing power where everything comes together, this is, I think, where USA first restricted, for example, EUV technology, where you have like this below 10 nanometer process, or when you hear like the new Apple chip, even for the iPhone with 3 nanometer. This is technology which cannot be produced in China at the moment, because there you have the most computing power on the smallest space together.
Thank you. Now, following his event with Morris Chang, Chris Miller spoke exclusively with Taiwan Talks host Alex Lee on America's chip strategy. Miller is the author of FT Business Book of 2022, Chip War, and Tufts University Associate Professor of International History. The full interview is on our YouTube channel. Here's a short excerpt.
If you listen to U.S. government officials, they've articulated the goal of growing the gap between what China can produce and what the U.S. and partners like Taiwan can collectively produce. And right now, there's a gap of at least 5 years, maybe slightly more than that in terms of manufacturing capabilities. And the U.S. wants that gap to grow over time. I think that there's no doubt that China's going to find ways to domesticate some of the tools that are being prohibited over some time horizon. There's lots of bright engineers, lots of money going into Chinese industry. But I think, as you've alluded to, the key question is not, can China produce 2023 levels of technology, but can they catch up to wherever the cutting edge is by, let's say, 2033? And in 1 decade, if Moore's Law continues, that will be 5 Moore's Laws ahead of us. Sure. Which means 5 doublings of the amount of computing power on a chip. And so if by 2033, China's caught up to where we are in 2023, they'll be far behind. And that's why Moore's Law makes it so hard to catch up. I think with China, we should expect some advances, but the question is not will they advance, but will they catch up to our advances? And that's a much more difficult challenge.
Professor, can you explain to me why China isn't able, or any other country is able, to leapfrog this process?
Okay. Yeah, there are 5 reasons. A perfect combination in Taiwan. The first one is the talents. And the second one is the collaboration service mindset. And the third one is the manufacturing essence that we have been focused for decades, right? And then the other is the ecosystem that has been built since Morris built the TSMC and also UMC, and the foundation and the infrastructure. And the other one is the process complexity. I will explain a little bit more. The talents, if you look at the Taiwan engineers, highly educated, and their first choice engineers to TSMC or to the semiconductor industry, right? Because the pay is relatively higher. And they would like to serve, right? They provide a service. How about manufacturing? You can make money, also you provide the most advanced technology worldwide. So they feel honored. And also they are very dedicated and honest and friendly, and also very collaborative. So that makes these, including managers and engineers, so that makes it very unique. I think that is a culture. It's very hard to replace or copy because of the culture, the mindset. You know, Taiwan, from day one, decades ago, we have founded different products, not just semiconductor, right? So it's the mindset. The second one is the collaboration, because all the engineers, they think that if I provide good service to my customers, I feel honored about that. Yeah, so that is also another culture. And after decades, for the decades, we have been, a lot of R&D investment on the manufacturing excellency. So look at that. So many customers, they drive the technology in your fab. So you have to meet all the customer needs. So all those manufacturing excellence built from that. And they invest more and more in R&D to make it the more cutting edge possible. And the other one is the ecosystem, the infrastructure, the collaboration with the material supplier, software supplier, and also the customers. So that kind of trust each other, especially in democratic camps. They can trust each other. And then so that is the model, especially like I mentioned, Morris Chang, and build a foundry model, so that is so robust ecosystem that is very hard to copy. And the end is the fundamental wise, it's the high tech high-tech business manufacturing. So you need a lot of engineers, and each step there are thousands of steps for cutting edge. No single step could be failed, or otherwise you do not get yield and all the performance. So you have to be very dedicated and work very closely among the engineers. So it's so complex, so it's complicated, so very hard if you do not have that mindset or the dedicated to work on that. And for years, you just focus on that, and it's very hard to make the copy on that. Yeah.
That's great summary of the sort of culture and the ecosystem. Tim, could you address the technical side? So in terms of Moore's law, seemed to be what Chris Miller was saying was China can't do any leapfrogging, to basically, meet us, Taiwan, US, in 10 years' time. They have to go up the ladder, up the rung. How does that work?
Well, every technology node builds on the previous one. There's going to be a lot of crossover. So you go from, say, 28 to 20 and then to 14. Some of the stuff that you're doing at 14, you will have mastered in 28, but there's going to be a whole lot of new things. So there's new parts of the recipe, new equipment you've got to learn how to use. Even the supplier might not quite know how to use it. They're sitting in the fab with you, working it out as well. It doesn't come with a nice, easy instruction manual. Every client's going to have to tweak that bit of equipment. So it's always building on itself. And if you compare the semiconductor industry to, say, the car industry, you've got a very long life cycle. You work out how to make a combustion engine and you tweak it. And you've got about 10 years of life out of a car or the car engine, or even rocket technology. Once you know how to fire a rocket, you always know how to fire a rocket, and maybe you can tweak it. With chips, you might work really, really hard to absolutely nail 14 nanometer. And you can celebrate and drink your champagne and say, wow, we did it. But your competitor is already racing ahead to 10, right? And you pause for one moment, your competitor is already 2 years down the track. So as Chris Miller pointed out, 10 years, that's 5 nodes. 2 to the power of 5 is 32. So if China was held dead in its tracks and the rest of the world advanced on for 10 years, they'd be a power of 32 behind. Now, it won't happen that way. They'll slowly move forward. But if, for example, China was moving forward one node every 3 years instead of 2 years, within a decade, they're basically 8 times behind, or 1/8 of the catching up in terms of the amount of transistors on a chip or per square inch. And so you can do all this, all the maths is there. And we're talking about things like AI, where the amount of pure processing power is very, very important. All that the US and its allies have to do is slow China down. They don't have to stop China. And I don't think that's the goal. No. They want to stop them at 10, and then if they manage to move forward to the next nodes on their own, they may do it. And they are at the moment doing exactly what they should do, which is trying their own moonshot projects and trying to find their own ways around and come up with new processes that the rest of the world hasn't come up with. And if they do land it in 5 or 10 years' time, they may catch up with everybody else. But then they catch up, and then they've got to look forward to the next node, which is 2 years away, and they've got to start sprinting again. So it's very, very, very difficult to catch up once you're behind. And if you do catch up, you can't stop. You've got to keep moving forward, because every generation is built on the previous generation, and that's collaboration. Taiwan has not done it alone. They've worked with the Dutch. They've worked with the Americans and the Japanese and the Koreans. TSMC didn't get where they are because they're alone. They got where they are because they're working with everybody else. The big risk for China is if they get cut off from everybody else, they've got to figure out all of those 1,000 steps on their own. And that's really, really tough.
Hello, I'm Ian Kavat of Taiwan Talks. We just discussed the concerns of TSMC founder Morris Chang about diversification and friendshoring. What we want to know from you is whether diversification will be the undoing of the chips industry. Let us know in the YouTube comment section. Also, if you like our shows, please hit like and subscribe to our YouTube channel. See you again.